So on the W&B platform outline, you can see here we've got modular tools from having data sets that you're pre-processing and preparing through experiment tracking for developing new models, all the way to plans to build tools for managing models that are in production and governance on that end. And so what this more complete picture gives us is a set of modular tools that can solve pain points across the ML lifecycle. And so within this vision, today I'm going to highlight the model management component. And this is our key focus right now for improving the way people can manage the models that they're already logging to us, make it easier to coordinate and collaborate centrally, and ultimately have an automation cycle where you can automatically retrain a model when you have new data, or you can automatically evaluate and test a model once you have a new good candidate that you might want to replace, the current model that's in production with. So what are the key pain points that we're hearing? Well, when we're talking to customers, a key theme of collaboration reproducibility consistently comes up. So issues like siloed projects, it's hard to discover what are the existing relevant models that people have already trained my team, and how can I pull them down and use them? And if I can find those models, it's often not clear how to reproduce and reuse those previous pieces of work without something like a model card. We also have issues around governance and lineage frequently come up. So problems like having ad hoc handoffs between teams where there's no standard process where, say, a researcher hands off a model to an ML engineer to then productionize, where sometimes that's even like sending a Slack message to say something is in the S3 bucket and go look at it. Now that process, also potentially causes unclear lineage. If there's this ad hoc handoff, then maybe it's not clear where a model really came from. What's the exact history, the code, the dataset versions, everything that happened upstream to produce a given set of model weights. So governance and lineage was a key theme that we kept hearing. And over here on the right, I've got this funny screenshot that I love from an ODSC article where it's basically a handoff point that's a Finder file system with a IPy notebook, training a model. We've got a scraper notebook, and then a bunch of different experiments and models loosely in here. And I've seen before folks basically say, "Hey, I got a new job. Here's my desktop with a bunch of notebooks and all of my research. Good luck. Here's all the stuff that I've been working on." And without that standardized process for tracking where something came from, and then organized way of communicating then how to use it, it ends up becoming kind of a model, soup of different models. So the last theme that we're really hearing here is automation and CI/CD. So right now, there's often a lot of manual testing. Even once you have a model in production and are iterating on it, there's still a lot of team members are manually running ad hoc scripts to test new candidate models, hopefully on the latest evaluation data set, but sometimes it's not clear if the model in production was evaluated on the same test set as the new candidate that you're testing. So issues there around kind of the manual process of testing. And then ad hoc retraining. So it's often slow to retrain a model on the latest data, especially if there isn't this automated system to test and deploy. So what are our solutions? How do we make this process better? Well, in working on W&B models, we're focusing on collaboration reproducibility first. So having a central model repository, like this little snippet here that you see on the right. And that's the live demo that I'll get into in a moment. So having all of the things that you're logging in one central place. Also communicating centrally with model cards and metadata. So having that context of the exact learning rate that you used when you train the model, or the exact git commit and the diff patch, any of the details that you need to reproduce where that model came from, we try to capture that automatically and make it easy to access from this central page. For governance and lineage, we're making it easier to have this standardized tracked lifecycle. So adding a couple of lines to your different scripts in your pipeline means that you get to track exactly when a model moved between different stages. And we also capture when you move a model between staging and production and who signed off on that. We're also capturing this complete traceable history. So if you think about, a tweak to a pre-processing step could actually ultimately really affect the, accuracy of the model downstream, then capturing the changes upstream to that pre-processing step is also really critical to making this entire process traceable. And so with W&B and those couple lines of code tracking upstream, you can capture that complete history. And I'll show you what that history looks like in the UI here in a moment. And then third, that automation and CI/CD piece. We're allowing you to have this comprehensive model evaluation and it happen in a central place. So you can automatically evaluate models that are good candidates for the registry. And my colleague Igor will touch on more of this automation for eval and retraining in his section right after this. So now I'll get into a live demo and talk specifically about the collaboration reproducibility, having that single pane of glass for all of your model development, and then governance and lineage, so how you can keep track of when people move things between different stages. So here in my next tab, this is what the model registry looks like. What you're seeing here on the right-hand side in this sidebar are different registered models. So these are different tasks, like detecting a stoplight or a model for mapping. In this case, we're looking at nature classification. And here we can see each different version of the model that's been added in here. So how this works is different researchers are iterating on this problem. They've got maybe dozens and dozens of model checkpoints in different projects. But when they have a good candidate, they can link it in here, and it'll show up here in this table. So a new candidate is added to the registered model. And once it's linked, I can then dive into any of these individual models and see more details. Now here, my colleague has actually filled in this really clear model card. So I can see what the expected inputs and outputs are for this given model. And I can also get back and see exactly what the run was that produced this model. So if I want to see things like what were the training curves, or what were the layers of the model that you were training, I can see exactly that. I can also get back to the exact version of the code. I can see when it was trained. I can see the Python version, the configs, so any hyperparameters. All of that is accessible just with one click from the model registry. Now I can also see a summary of the metadata here, right on the metadata tab. So I can look at those hyperparameters. And if I sent this to someone else, they could pull up this snippet of code and pull down my model and start to use it with this simple chunk for usage. Now, for files, you can save anything into a model. We aren't going to restrict what you're allowed to save into this versioned folder of data. So you could imagine having your H5 file in here, but you could also imagine having additional files that are maybe helper scripts that someone who's using the model might need. So we try to be flexible and agnostic in this regard, so you can decide how you're managing the model that you've saved here. And then lineage, this is the exciting part that I was really looking forward to getting to. So we're looking right now at a model artifact that was saved to W&B and then linked into this registered model. Now, where did it come from? I can step one step back in the DAG and see, okay, that's the run that we already opened. If I open that again, you'll recognize this is that same run that we were just looking at for Keras model training. Now, what did that run use? I can open that up, and that's the training data that was pulled in to train on. And I can see exactly the version of data that was used to train that model. In this case, I can even get in and see the exact data itself. And if you zoom out, you can see all of the other steps that happened upstream of that ultimately the model that we're looking at. So I can get back and see the full history of where this thing came from. Now, inside this specific registered model, we also have different stages, right? So we have production, we have latest, and you saw that here in the versions table. So how do I identify who moved this model into production? Well, here in the action history, you can see it was me 15 minutes ago. I added the alias production. So I moved this version of the model into this state. And now if I wanted to add a new model in here, I could also track that on this page. So let's try that now. Let's imagine we have a project that we're working on, like, for example, this model registry end-to-end demo project. And here you'll recognize this project page if you're tracking experiments with W&B. So here on the left side, we've got runs that are tracking different training jobs, different instances of training a model. And we've got two different runs, green and purple. And it looks like over here on the accuracy chart, green at the end of training is performing just slightly more poorly than purple. So I'm going to click into this run here and see, okay, it looks great. I can look at any of the files, the model architecture, and I can pull up the artifacts and see the models that it produced. And I know that that last step is the one that I want to use to then link into the registry. So I'll go back to my all versions table. We can see that, okay, latest was version 5 just now. And here I can then pick this latest artifact and pull it in and link it. And apologies for my internet. It looks like that's taking a moment. So ultimately, what the model registry is providing us here is a way to capture across the different projects that you're working on this central list of the best, most useful versions of models. And what that will give us is an organized view that anyone else, even if they haven't been involved in the process of model training and development, they'll be able to come in and identify, here's the model that's in production, here's the new candidate, and this is what I need to know about it in that overview, in that model card. And so what that's giving us is that communication, collaboration in the central hub, and then that ability to trace exactly what's happening, both from the metadata and the lineage that we touched on, and that action history of every step of things that have changed. And so ultimately, what this tool is about is giving you that central place to discuss models as a team and to hand off models between different stages of your pipeline. So now we've talked about those core collaboration and governance pieces. Next up is automation and CI/CD. And this is a really exciting next step. How do we take those actions that you saw in the model registry and move models through that lifecycle? So that's, for example, I have a new model that is in production, and now we've got fresh data coming in from the field. How do I retrain that model on the latest data and trigger that automatically when data is available? Or automatically testing the latest candidate model. So say a new model is linked in there to the registry. How do you automatically kick off like a test suite? Or now that model's passed all of these tests, it's looking good. How do we deploy that model to production? So I'll hand it off to Igor now to talk more about automation and CI/CD.
Thanks for the introduction. So I'm happy to talk about our Launch product line. Weights and Biases has always had the vision to integrate well with your existing infrastructure, and Launch actually gets its name for being able to launch jobs into that infrastructure. In terms of the goals of the product line, Weights and Biases cares deeply about reproducibility, as we want to make sure we're compatible with containerized workflows and work well with tools such as Docker and Kubernetes. We want to connect the ML practitioner to compute. So envision you have a hyperparameter tuning job that you want to run. You can then simply send that to a cluster, parallelize the work, and have the job complete much faster. And we want to make sure we abstract away the complexity of actually using that infrastructure and making sure that it's used and getting an ROI by having one central UI within Weights and Biases that you can launch jobs from. It's a UI that you're already familiar with your other tasks. And this notion of building a bridge between the ML practitioner in your organization to other personas, such as the ML ops engineer, and working with your IT team. We know that the practitioner really wants to focus on building models, running experiments. They don't necessarily want to deal with configuration files, Helm charts, and all the specifics around Kubernetes. So having a seamless way to connect to the infrastructure. So this is a visual representation of the workflow. So an ML practitioner may have a piece of local code that they're iterating on, and allowing them to then easily connect to a cluster, get access to more resources, and really power up their workflow. So let's actually dive into a demo and being able to create and launch a job through the Weights and Biases UI. Weights and Biases is flexible, so there's actually a variety of ways that we can create a job. You can run some samples code, have one line that corresponds to Weights and Biases. You can launch a job via a Docker image, weights and biases accepts a Git shot or a Git URL, or you can launch a job directly within the user interface. And I'll show you how to do that as well. So if we go to weights and biases UI, you'll see a new tab here that appears that's called Launch. And this is a job queue that now anybody within your organizations can send jobs to execute. Now, there's a one-time setup that's required to connect weights and biases launch to your infrastructure. In this case, my ML ops team has already made that connection, and this queue can then be subsequently reused by anybody within the organization. Now, let me show you how to create a job via both code and the UI. So let's start with code. So this is a simple training script that I have that's training a model on the fashion MNIST dataset, detecting the type of clothing. I'm using weights and biases to log some of the loss metrics, as well as some of the sample training images from the training dataset. Now, with this one line of code, weights and biases will automatically capture all the information that's needed to reproduce this job. And I'll show you that within the UI. I'm also passing in some configuration parameters into the model. With weights and biases launch, we'll actually expose these via the UI, and these will be knobs that you can tune and be able to launch new experiments from. So let's run this piece of code. And if I copy and paste this, you can see that the job is now executing. All the results are now being streamed in real time into the UI. Now notice, weights and biases, again, automatically going to capture that the hardware the job is running on. They get information. We capture the code that the job is running on. We capture all of the requirements and dependencies. If you launch this job with a Docker image, we can capture the Docker information as well. Again, the goal is full reproducibility. So let's actually now add this job to the queue and execute it. So if we go to weights and biases launch and we add a job to the queue, again, we accept jobs from a variety of these sources, but let's clone the existing run that I have just completed. Here, what you see is a parameterized version of that job. And remember these knobs that I mentioned via the training script? I can now overwrite any of these via the UI. So if I wanted to change my learning rate or change the amount of epoch that the model is trained upon, I can do that directly from the UI. If I want to then send this job to my cluster or the infrastructure of my choice, I can then now select that as a resource of where the job is going to be run. So if I push this run, the job has now been enqueued. And I have an agent set up to automatically listen for this run, and it will pick up upon and start rebuilding the run and start executing. And notice everything I'm doing, I have a sample piece of training code. I'm just clicking buttons via the UI. I don't necessarily need to deal with YAML files. And it allows me as a practitioner to much more effectively collaborate with my ML ops team and with my IT team. Okay, boom. You see that the job has already started, and then the new job is now running, and the results will now be streamed in real time via the UI as well. Perfect. So this job is now running. So zooming out, again, as Phil and Carey mentioned, the vision of weights and biases has always been an end-to-end platform, and Launch is a platform layer and a generic job execution layer that will allow us to expand to other parts of the pipeline. In a subsequent release, we have actually just released a functionality that's known as triggers, where you can trigger these jobs contingent upon an event. So envision you log a new data set within weights and biases. You can then automatically trigger a model training job to run, a model evaluation job to run. You can trigger a suite of tests that you can test against all of the metrics that weights and biases captures. And so Launch is a product line. This is a sneak peek. It's a private preview product, but it's undergoing rapid evolution. So stay tuned for the subsequent releases.